The Tower of Hanoi, also called the Tower of Brahma or the Lucas Tower, was invented by a French mathematician, Edward Lucas, in the 19th century. It is associated with the legend of a Hindu temple, the Temple of Benares, where the puzzle was supposedly to increase the mental discipline of young priests. In the legend, the young priests were given 64 gold discs. The priest's goal was to recreate the stack on a different post by moving the disc one at a time to another post, with the rule that a larger disc could never be placed on top of a smaller disc.
The Tower of Hanoi is a mathematical game or puzzle. It consists of three rods, 1, 2, 3, and a number of discs of different sizes which can slide onto any row. The puzzle starts with one disc, and it's stacked in ascending order of size on one row, the smallest at the top, thus making a conical shape.
The Tower of Hanoi consists of 3 pegs or towers, 1, 2, and 3, with a certain number of discs represented by one over the other. So to play this game, you must move the stack to another peg in fewest possible moves, following the simple rules. 1. You're only allowed to move one disc at a time, and 2. Larger discs may not be placed on top of a smaller disc. We call that a recursive pattern from the moves necessary to transfer 3, 4, 5, and 6 discs. We can find a recursive pattern, a pattern that uses information from one step to find the next step for moving the number of discs from one post to another post. We can observe that the number of steps almost double, so the formula in computing the number of moves you have to make is 2 raised to n minus 1, where n is the number of discs. And that is how you play the Tower of Hanoi.
Let's try to solve a puzzle. Take an example with 3 discs. Disc 1 on top on disc 2 and disc 2 on top of disc 3 at peg A. The target is to move disc 3 disc to peg B. Step 1. Move disc 1 to peg C. Move disc 2 to peg B. Move disc 1 to peg B. Move disc 3 to peg C. Move disc 1 to peg A. Move disc 2 to peg C. And move disc 1 to peg 3. This solution takes 7 steps. What if you have 4 discs? To solve the problem of moving disc 1, 2, and 3 from peg A to peg C, you must move disc 4 from A to C. This solution takes 15 steps to solve the puzzle. The same goes with 5 number of discs. The solution takes 31 steps to solve the puzzle. same also goes with 6 number of discs with 63 possible moves. So when we worked through in transferring 3, 4, 5, and 6 discs, we can see a pattern to the puzzle. Now we call that a recursive pattern, from the moves necessary to transfer the several number of discs. We can find a recursive pattern, which is a pattern that uses information from one step to find the next step for moving the number of discs from pose A to pose C. We can observe that the number of steps almost double every time you insert another disc.
Using mathematics, you can calculate that even when the priest found the most efficient way to solve the problem and move the disc at a rate of 1 per second, it would take almost 585 billion years to finish the job, equivalent to 18 pentillion, 446 quadrillion, 744 trillion, 73 billion, 709 million, and 551,615 moves. That is more than 40 times the age of the universe. The legendary tale of the monks gained traction when it was depicted in several publications. Henry de Barville, editor of the journal La Nature, also wrote about the legend in the late 1800s. The setting of the legend occasionally varies and thus included the city of Hanoi in Vietnam. Given a stack of N discs arranged from largest on the bottom to smallest on top, placed on a rod, together with 2 empty rods, the Tower of Hanoi puzzle asks for the minimum number of moves required to move the stack from one rod to another, where moves are allowed only if they place smaller discs on top of larger discs.